1, 2, 3, zkouška rozhlasu.
So, if you didn't have enough of Docker already, here's one more session for you. Vojtěch Juránek, who is within middleware group in Red Hat, will now tell us something about how to use Docker with continuous integration.
Hi, everybody. So, in this talk, I'd like to share with you some ideas how to improve your CI workflows and how to avoid some common pitfalls and maybe also improve your integration testing using containers. As beside other things, I'm also a Jenkins developer, so I will speak quite a lot about Jenkins integration with Docker, but I will also mention other tools which can help you simplify using Docker in your continuous integration process. So, as Dan Walsh says, Docker, Docker, Docker. Everybody speaks about Docker, and I think that every second presentation here in DevCons at least mention Docker. So it may look like that Docker is something like silver bullet, which can fix all your problems. So is it true also for continuous integration and delivery? So surprisingly, no, it isn't. So if you expect some magical recipes, you have still time to leave and go for another presentation. But I will try to persuade you that containers can help you at least a little bit to avoid some problems with your tests. So first, I would like to list some of the common problems. This is, of course, not a complete list, but from my experience, these issues are quite common. So very often is false negatives. This means that your CI build fails but it fails not because of some error in your code or issue with the test, but it simply fails because there is some issue in built environment. For example, some tool which your test suite relies on is missing, is misconfigured, or there is some interference with other builds, or if you have permanent machines, previous build which runs there had left there some stall processes and so on. So basically everything is okay with your code, but there is some issue in your built environment. Another issue which usually happens if you provision machines dynamically, for example, in a cloud, is that you can't debug the issue because the machine where the build run already returned back to the pool, or it can happen also if you have static machines because, for example, there already run some other build and it destroyed the environment or did some changes, so you can't reliably debug the build and found out what has happened. And another quite common issue is that developers QA has completely different environment, and it's far different from production environment. So how many of you have ever heard from your colleague, or maybe you even said it, that, hey, how could happen that it failed because it worked on my local machine? So did you ever heard this? I think that yes. Personally, I heard this many times. Sometimes even in stronger formulation that Jenkins is broken because it fails some tests which are passing on my local machine. But in, I would say, 80, maybe 90%, it turned out that there is no issue with Jenkins, but there is some issue in the code or in the test which appeared in different environment. So this is also good to keep in mind that your environment is quite often different from production environment. And so it would be nice to test with in an environment which is same or very close to production environment. But how to achieve it? Because it's quite often pretty hard to set up the environment which is the same as production, because especially in some big applications, it can count many machines, for example, load balancer, behind that several clustered servers which use databases as a backend, use Kerberos and LDAP for authentication. So it's pretty hard even to set it up and start it as a part from your test suite is even harder. So sometimes this integration tests are completely skipped because it's too hard to set it up. And another issue is speed. The idea behind CI is that you get the feedback as soon as possible. So you have all the changes in your head, and it should be pretty easy for you to fix the issue if you introduce some kind of error. So if your build waits long in the queue and then provision machine a long time, and the whole process take a long time, it's not that useful as it could be. So my first tip is to define and share your development and production environment, which means try to unify your environment in a container and make it as close as production. it doesn't mean that it has to be the same. For example, when you are developing something, you usually run servers in debug mode and so on. But even that you unified the environment is a big step further, because all your team, or also QE and other teams which interacts with you, can have the same environment, can easily, if you hit any error, you can easily share with others. And if you break something, you don't have to spend a lot of time configuring again the whole environment. You just simply throw away container and start the new one. And it's especially useful when you're starting a project. You usually do many configuration changes and optimization and playing with it, and this can very easily provide you a way how to do it very easily across the whole team. And it's also some kind of DevOps approach when you are acting partly as an admin of the whole environment. So the second one is that if you defined this unified environment, so it's good to share with your team and other members of other teams which use the product, but why not use it directly in your continuous integration? So basically you take the container and run the test within this container, which means it will run in the same environment as on your local machine. So again, if anything fails there, you can easily check on your local machine. And as containers can be started very quickly, you can start fresh container for each new build. So basically, you by this avoid all the issues like interference between builds, stale processes, and so on. Also avoid misconfigurations and other things. Of course, this could be achieved by many other tools, but Docker makes it super easy. So there are really, I don't see really no reasons why not to go this way, because you just define the container and push it into your CI, and that's it. Okay, so does it sound good to you? If yes, so obvious question, how to do it even more easily. For example, starting new container for each build. So the answer, or my answer, is choose Jenkins. As far as I know, it has the best Docker support in CI field. To be honest, I don't use other CI tools very often, so I'm not sure to which extent other CI tools provide support for Docker. I know that, for example, Circle CI provides support for Docker, but it's paid service, and other tools like Travis, I think, run on Docker, but I'm not sure if it does provide any Docker support, so maybe if you know. Jenkins, I think, even if there are still some minor and annoying issues, because this integration with Docker is under heavy development, so I think that it's by now it's quite usable and provide basically everything you need. So let's take a look on the first Jenkins plugin. It's surprisingly called Docker plugin. It's the most complex plugin which could act as a cloud provider of Docker slaves. It basically means that Jenkins will start dynamically new containers and will connect them as ordinary Jenkins slaves. It's done based on the jobs queue in a build queue. So you basically define some image, assigned a label to this image, Docker image, and then the same label you will assign to your job. When you schedule a job, it will go to the queue. Jenkins realizes that this kind of label can be served by Docker will create container and schedule the job in this container. So there are some Docker images which you can use for playing or testing, one based on Fedora, one Ubuntu, and there are many on GitHub, Git registry or Docker Hub. You will find really plenty of images. This I selected just that I know these two works. Okay, so here's sample configuration, nothing special about it. You just specify in a global Jenkins configuration, you specified the Docker URL. You have to configure Docker to listen on TCP port. This is the only condition to make it running. And then, as I said, define your images. The top two fields are the important one. You specify the ID of Docker image and then assigned label to it, and then probably provide some credentials how to SSH to the machine. And you have plenty other Docker options which you can specify, but this is not important right now. So this is sample Docker image of such slave. It requires to have JVM and provide SSH service. So this is some small limitation, but you can use it as a basis for defining your own Docker image, which is adjusted just to your needs. So you basically here add yum install and tools which your application needs, and you can do some other configuration. So it's pretty easy. You push the image somewhere and can start using it, and you will have a clear environment for each build. There are some or many other actions you can do. For example, you can submit the container. So, for example, if you want to store your build for some time, you can push it, and if something happened there, you want to investigate, you can go back and investigate it again. And there are some many other options, but I'm not going to list all of them because I will also other plugins which do provide similar functionality. So the advantage of this plugin is that it's quite complex and provide or can handle a lot of things, but the downside is that the configuration is also could be a little bit complex, especially to find out where various actions in configurations are and how to make it exactly running. And there could be also some issues when something goes wrong because it's not very easy to debug it. So, but I hope that by now everything should work, but I'm not sure. I definitely tried provisioning Docker slaves. It works, but I'm not sure if other things like committing the build and so on works. Hopefully, yes. Okay, so when you have defined your environment, so another logical step would be to embed your application into the container. This doesn't necessarily mean that you have to deliver your application to customers as a container. You can use just to share with the rest of the team. So imagine that you have, for example, application which is a little bit complex to configure, so you can do it for your QA, that you will provide it for them as a Docker image which they just start. Or you can use it in a whole Docker environment as for integration testing. You will start containers and start container with your application and will run part of the test suite, for example, which access the web UI or something like this as part of the testing. So it basically means that you just, for each build, you build also the Docker image of your application. But it should be pretty fast because Docker does a lot of caching. So here's the picture shows how caching could be powerful. And by the way, if you are not aware about it, explain how cloud works. So you don't have to be worried that your build will take too long or something like this. And again, you can easily share what you get by pushing the image into the Docker registry. So, as I said, the Docker plugin could be a little bit complex. So there are other Jenkins plugins which are more lightweight and focused on some small task. Other such plugin is Docker build publish plugin. The motto of this plugin is all you need is love and a Docker file. And this explains what it does. It just takes your Docker file, build image from it, and push it into the registry. I don't even have here any configuration because it's pretty self-explaining and trivial. Really, it's very easy to set it up. Okay. So this is probably the most important point I want to make, and it's idea to use Docker for better integration testing. So as I mentioned, integration testing could be very hard even to set up, implement in your test suite. And even, for example, if you have client-server application, you probably in your integration test start server, then client which tries to connect to the server and verify the response. So this is pretty easy, but Docker can be useful even in this pretty trivial setup because, for example, in this case, what you typically do is that you start both servers on localhost and it communicates over a loopback. So when you push it into the production and it communicates over the wire, there could be again some other issues. I saw it again many times that everything works nicely in a localhost, but later on in production there were many issues caused by communication going over the routers and so on. So even in this let's say trivial use cases, it can again help because Docker image at least communicates over VLANs, so there is at least, it brings it a little bit further to realistic scenarios, and therefore all your testing is more valuable. So this means that you have prepared image or several images of your production environment, and you have to start it before test suite runs, and after it stop it. This can be achieved in Jenkins by another Jenkins plugin, Docker build step, which doesn't do any assumptions about your images. It can be arbitrary. Docker image don't have to contain JVM or SSH service. It just start the image or allows you to do any operation with image or container you like. So you can simply put it into your job definition as a build step and, for example, start the image. And then, for example, if you have a cluster of several servers, you can also, in the middle of the test, kill some servers and continue again with some tests which, for example, test how your cluster evolves after when several servers leave the cluster and so on. It also provides some functionality like exporting IP addresses of started containers, which can be consumed, again, most likely by your test suite. And what I should mention, there's reported one issue with this, that this is not compatible with Docker plugin. So I haven't looked on it yet, but we'll do it soon. And we'll hopefully fix it soon if it's true. So, okay. So this was Jenkins, but sometimes maybe you don't want to make Jenkins as a central part of all your processes, and you want to use, for example, run it on your local host of a whole environment without Jenkins, or you can have some other reasons why you don't want to use it. So you maybe can consider, in such case, to use some dedicated tool which is specific to your language. Jenkins, of course, is language agnostic. You can use it for any kind of project, but if this is not the case and you want to use some specific tools, there are plenty of them. I'm mainly Java developer, so I will mention two from Java world, but I'm pretty sure that there exist similar tools for your favorite language or framework, and if doesn't, develop one, because here in this URL there is really lots of libraries for various languages which implements communication with Docker. So you just basically download library, and it's usually a couple of lines of code to implement extension to your favorite framework. So I will talk about Maven Docker plugin and Arquillian Cube. If you search GitHub, there are plenty of Maven Docker plugins. Maven, if you are not familiar with Java, is one of the build tools for Java, which have predefined stages and goes through these stages and automate build process and run test and installs somewhere the bits. So here's, as you can see, there are plenty of them. For example, I choose this one. I like this one, and I will probably show you in a demo, so I will this here for completeness, but we'll skip it for now. This is configuration of Docker plugin and failsafe plugin, which runs the test. And in a short, also, I will mention Arquillian Cube. Again, if you are not familiar with Arquillian, it's a test runner which contains some cool features like dependency injection in your test. It contains lifecycle management of containers. Here, containers, I mean web server. It was originally developed for testing Wildfly and JBoss EAP server. So here, by container, I mean Java servlet containers, not Docker containers. But Arquillian Cube is extension of Arquillian to Docker, and it's currently in alpha version, so you can expect some minor bugs, and also you can expect some further development. Okay, so let's go to the demo. I prepared some trivial application which queries LDAP. So how would you test it if you want to test your application with LDAP? So any ideas? So we'll probably have to start LDAP server, because mocking LDAP wouldn't be probably an easy task. So you have somewhere in your test environment have one machine with LDAP, or you have to start it somewhere locally, which I said is maybe not that good idea, and moreover you have to have root permissions, which again often is not the case, because, for example, if you run it in some environment which is shared with other fork other teams and use static machines. This is not allowed because you can easily break the whole environment. So in Java, there are other solutions like Apache Directory Server, which can be embedded into your test suite, but it's not very easy to implement. So, for example, here, Docker container would be very good fit. So I did it about a year ago for Infinispan when I wrote this security test suite for Infinispan. And when I finally, because we don't want to put by that time Docker into our test suite, I finally go with Apache Directory Server, but I start whole the prototyping of test with the Docker. And writing this Docker file with LDAP took me, I don't know, about 2 hours with almost no prior knowledge of LDAP configuration. I just Google everything I need very quickly and make it running. So it's just few lines of code and it's very quick to set up. And here what is very simple Java application with queries LDAP. The only thing you have to pass to it is IP of LDAP server. And it will then allows you to run some queries to LDAP and returns back you the results. So here is sample test. It just creates new instance, query, do some query, because in the Docker image, I forgot to mention, but besides it starts LDAP, it will also populate it with some data. So it queries LDAP and verifies that the answer from LDAP is what you expect. So, first what I can show you is how to do it in Jenkins. So you can define a simple job. I'll probably make it, maybe two more. Here, this demo and presentation is on GitHub, so you can download it and play with it if you want, and go through all source code if you are interested in it. So here I download the demo from the GitHub. Then I have, let's say for simplicity, let's say I have already existing container in my machine, so I will only start it. And here I will just invoke Maven, which builds the application and execute the test. And the only thing is that I will use this system property which is injected by Jenkins, which contains IP of started container and will pass it to Maven as a variable which is used in my test to resolve the IP of the LDAP server, and after that I will stop the container. So let's try to run it. Oops. So it's waiting for, I'm not sure if I'm disconnected from the network. Okay, it seems to be some network issue. Okay, sorry. but I run it a few minutes before the presentation to make sure that it works. So here's at least the output of previous build. So here, this blue line is info from Docker build step plugin that it started a container. Here is the Maven build, and here you can see that it ran one test and everything passed without errors. And here that you can see the container was stopped. So pretty easy, and okay, I will kill it. Just believe me that it works. Again, as I said, you can download it and try it yourself. I'm not sure if I have the job configuration submitted into the repo. I will do it after the presentation. Okay. And another option is Maven plugin. So I will briefly go through it. Here you just define again that you want to start or start and stop container. It's again pretty easy, basically the same as in Jenkins demo, and in Maven there's a plugin which is called failsafe, which run integration test, and in the configuration of this plugin you just passed again the IP address of started server. This Maven Docker plugin export the name of the variable is a little bit different, so it's a little bit different name. So you have always, it's quite common that these tools will export the IP addresses as environment variables. So all you need to do is just check the name of this how these environment variables are created. So this shouldn't need an internet connection, so I will hope it will work, at least this one. So Maven clean verify, and I have there also some Arquillian tests, so I will use Maven profile. So now it started. As you can see, it was pretty quick, and where it is, there is a lot of output from the Docker clan, but here you can see Maven out or failsafe output that one test run and zero failures and zero errors. So everything went fine, and as you can saw, it was pretty quick. So that's basically all. So just to sum it up, you can put everything together. Just define your development environment, which is as close as production one. Share, build it as a container, push it into the Docker registry so you can easily share with the rest of the team or other teams, and use this also in your CI environment as a build environment, and build and test your application in this Docker-based slaves, and also do the same with whole your application, and really try to consider if you can improve your integration testing with Docker, because I believe it can help you a lot, and with really minimal effort. You just create a container and it should be pretty easy, and you do it once, and basically that's it. And as I showed you, most of the steps can automate in your CI or some other tools which you like. So thanks for your attention, and any questions? Yeah?
What protocol do you use actually for connecting to Docker server? Do you use REST API?
Yeah, It depends on implementation. You can use Socket or REST API, but most of the tools I mentioned use REST API for connecting. So that's why I mentioned that, for example, Docker plugin needs Docker to be configured to expose TCP port.
And do you use REST API or use some special library for connecting?
Yeah, Docker itself provides REST API, and again, most of these tools I mentioned are written in Java and use Docker Java library, and this library under the hood used Jersey REST client, but there's currently a lot of discussion that this general library shouldn't depend on some specific implementation of JAX RC. So, for example, REST Easy users can build their application and use it. So there are some ideas to completely implement it, the REST client from scratch, but I'm not sure if it will happen. So currently it uses Jersey client. Any other questions? So if not, so thank you. And please provide me feedback.